So in this video we're going to use z equals cosine theta plus I sine theta, the representation of complex numbers in trig format, to find cosine to the power of 7 theta. So how are we going to go about doing that? We've got the cosine theta in here and we've got cosine to the 7 theta here. So we've got this I sine theta which we need to do something about. So the way to go about this is use this kind of formula here, z plus 1 over z to the power of n. And let's see where that takes us. So first of all, we've got what z is. Z is cosine theta plus I sine theta. So now we need to find out what z to the n is, which is cosine of theta plus I sine theta to the power of n. And using the identity, we can bring the n inside the input for cosine and sine. So then that gives us cosine of n theta plus I sine of n theta. So that's a valid input there for us. So now we need to find 1 over z. Now 1 over z will just be z to the minus 1. So let's find that first. So z to the minus 1, let's plug that inside here. That would then give us cosine of theta plus I sine theta to the minus 1. And if we did that, we'd have cosine theta, but multiplied by minus 1 using this same identity. So cosine of minus theta plus I sine of minus theta. So that's valid using this minus 1 input. So then if we simplify this using the cosine and sine identities, cosine of minus theta is the same as cosine theta. So that would then be good, that will work for this. So cosine of theta, and then here, sine of minus theta, that's the same as minus sine theta. So then we need to subtract I sine of theta. Okay, now we can use that same identity for cosine and sine using 1 over z to the minus n. So if I now write this as in z to the minus n, I've then got cosine of theta plus I sine of theta to the minus n. And now copying what we did here, we can just go straight to our answer, because what we're going to get is cosine of n theta minus I sine of n theta. So now we've got something we can work with, because we've got a cosine n theta and a cosine n theta. So now if we add these up, so now we've got z plus 1 over z. And then what I'm going to do is, I'm just going to bring the n inside for now. So this is going to look slightly different to what the original use of this is. So z to the n, that's this one, which is cosine n theta plus I sine n theta, and 1 over z to the n is this one. So it's plus cosine of n theta minus I sine of n theta. So I'll put brackets around these just so as you can see clearly what we've got for our inputs. Now if we add them together, I'll have 2 cosine n theta, and these two will cancel out because one's positive, one's minus. So that's what I've got for that. Now if I set n equals 1, I've just got 2 cosine theta. Okay, 2 cosine theta. So now I've got away from my sine theta because I only want cosine to the 7 theta. So now in the case when n equals 1, I've got 2 cosine theta. But I want to now raise this to the power of 7. So if I do that, I've got z plus 1 over z to the power of 7. Let's expand this out using the binomial theorem. So if I do that, my binomial coefficients, I'll have 7 choose 1, which is the same as 7 choose 6, which gives me 7. Then I want 7 choose 2. 7 choose 2, which equals 7 choose 5, which gives me 21. And then I want 7 choose 3, 7 choose 4, which are the same. 7 choose 3 equals 7 choose 4, which equals 35. So now expanding this out using these coefficients, let's go for that. So now I've got z to the power of 7. I don't need a binomial coefficient for this one because it's going to be 1, and that reduces to 1, so it's just going to stay as z to the 7. And then the next one, I need 7 choose 1, which is 7 is the coefficient. So I've then got 7 times z to the power of 6 times 1 over z to the power of 1. So that takes care of that. And then I've got to use these coefficients and reduce accordingly. So now I've got 21 z to the 5 plus 1 over z squared plus 35 z to the 4 1 over z cubed plus, and then we got z to the 3, so then I'm going to need 35 again. So 35 z to the 3 1 over z to the 4 plus 21 z squared 1 over z to the 5, and then plus 7, and then I've got z times 1 over z to the 6, and then I've just got here 1 times 1 over z to the 7, so 1 over z to the 7. Okay, right, what can we do with these? Well, we can certainly simplify all these off inside here, so that becomes z to the 5, that becomes z cubed, that one there will just become z, that one become 1 over z, this one become 1 over z cubed, so just write that one up there, and then this one here, that's a z, z times 1 over z to the 6, that's 1 over z to the 5, and that's 1 over z to the 7. Okay, right. Now what I see I've got here, I've got a to power of 7, to power of 5, to power of 3, to power of 1. Let's just put the 1 in there. And then I've got the reciprocal of each of these written down here. So I'm going to match them up. So then I get something that looks a little bit like this. And then I can use my 2 cosine n theta. So z to the 7 plus 1 over z to the 7. So that takes care of that. Now I want my z to the 5. So z to the 5 is 1 over z to the 5. And the coefficient for these is both 7. So if I write 7 times z to the 5, because that's what that is, and that one is 1 over z to the 5, that's also valid from what I've got here. Now my z cubed, let's put that in there. That will be with a 1 over z cubed, and the coefficient for that is 21. So I've got z cubed plus 1 over z cubed. So that's worked out really handy. And now my 35, I've got z 1 over z. So plus 35 z plus 1 over z. Okay, right. Well, now I can use this identity here that we worked out before. That's coming really useful. So now I can go, whatever they are, I can just plug in 2 cosine n theta, depending on what my indice is. So let's do that. So now I've got z plus 1 over z to the power of 7. So then that is going to equal, that will give me 2 cosine 7 theta. Okay, now what have I got next? I've got this one here, z to the 5 plus 1 over z to the 5. So that's going to give me cosine 5 theta. So now I've got 7 times 2 cosine, let's just take that out, cosine of 5 theta. Now this one here I've got 21, as I've got a 3, that's going to be cosine of 3 theta. 2 cosine of 3 theta, and here I've got 35, 2 cosine, as I've got n is 1, it's just 2 cosine theta. Okay, Now we've got this far, so what we're going to do now is make a bit of space on the board, and let's finish off our identity for cosine to the power of 7 theta. Okay, so this is where we are up to so far, and now we want to get cosine to the 7 theta. So cosine to the 7 theta. Now we've got 2 cosine theta is represented like this when n is 1. So we've got 2 cosine of theta. Now what we want to do is find that when it's raised to the power of 7, which is what we've done here. So if I raise both of these to the power of 7, then I can simplify out what I've got here. So I've got 2 cosine 7 theta plus 14 cosine 5 theta plus 42 cosine 3 theta and 35 times 2, 70 cosine theta. Okay, now 2 to the power of 7, that gives me 128. So 2 to the power of 7 is 128. So if I divide both sides by 128, I will get my cosine 7 theta on its own. So let's do that. Cosine 7 theta, divide by 2, sorry, times by 2 and times divide by 128. I'll have 1 over 64, and then I'll have cosine 7 theta plus 7 cosine 5 theta. Oh, don't need the bracket, not just yet. Plus 21 cosine of 3 theta plus 35 cosine theta. And that will be my cosine to the power of 7 theta. And that takes care of our answer using complex analysis. Okay.